Hello and welcome to TidyX episode 106. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes and you can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, and Tidy_explained is on Twitter, where you can find the both of us. Tidy.explained at gmail.com is on Gmail, where you can find the both of us. You can also open up an issue on the GitHub repo, or certainly like and subscribe on the YouTube channel and drop a comment or question in there. And of course, if you enjoy our show and you'd like to support us, we do have a Patreon page, and we are appreciative of everyone who has shown us some love there as well.
We love it so much. We appreciate all the comments that y'all have been leaving, emails that you send us. We are really enjoying doing this, and we look forward to continuing to do this into the future. All right, so we've been doing a couple episodes now, well, two, I guess, and now this will be the third, on discussing object types and kind of going into how they're supposed to be working, the way you can interact with them, and their benefits to like why they even exist. And last week we covered a lot of like these base type of objects that exist in R, from like integers, booleans, all the way up to how you convert or how those go to build up vectors and then matrices and data frames. And so that kind of gives you a good idea of how they all work together. But those, of course, aren't all the type of objects that exist in base R. There's a multitude of them. And so this week we're going to be going over another object type. Patrick, do you want to tell us what we're going to be going over as I share the screen?
Yeah, we are going to talk factors today. So last week we talked about a few different object types, and we purposefully left factors out because they are tricky and deserve their own episode. And so they get a full episode 106, and we're going to talk about what factors are, how they work, how they function, how you create them, how you re-level them, how they look inside of a regression model, and how they look when you try and plot variables against them. So here we are.
Exactly. Yeah. So factors are, I think, incredibly useful, and they are very tricky for people, especially if they're coming from not a like statistics or like computational sciences background. They're more in like the computer programming side of things. So it kind of behaves in a strange way. And really, at least the way that I think about them, and I don't come from a statistical background, but I worked with statisticians, so I was able to explain to me the value of factors from a statistics standpoint. And so factors are created using this factor function here. The way that the value that they add is that they provide a way for us to have different categories or enumerations of things without describing a priority or preference to them. So we're not saying that one is greater than the other, which is what you might see if people try to represent categories as numerical values like 1, 2, 3, 4, 5. If you try to do that as a regression, the regression is going to see those not as categories, even though we're like, well, obviously 1 maps to this category and 2 maps to that category. The regression's not going to see it like that. It's going to see it as a 1 or a 2 or a 3. So kind of think of them like in the empty cars data set, which has a bunch of car information, and if you extract the manufacturer's information, with the order in which you record the manufacturer shouldn't impact the regression results necessarily. So like a Ferrari shouldn't be seen as greater than a Mazda from a regression standpoint. You may like the car brand more, but that doesn't mean the regression should see them Ferrari is greater than Mazda objectively, right? Is that a good way to say it, Patrick?
Yeah, it's not going to change your model outputs. It'll change the coefficients of the model, like we'll show in a second. But the value of the model, the R squared, the p-value, the predictions that come from that model, those will remain unchanged, because under the hood, we're talking about Ferrari and Mazda here, under the hood, it's all the same data. The only thing that we've reshuffled is the relationship between everything, all the factors that we're looking at, and the base class, the intercept. And we'll go over that in a second.
Exactly. Now that we spent all the time talking about that, there is an option of providing ordinality to your regression. And so kind of think of this as category. There's still categories, but there is a relationship between them. And so think of like first, second, third as categories, but there is an order to them. Like first is greater than second, which is greater than third, but we still want to see them as categories.
Yeah.
And so that is an option you can add into your factors. And then one piece of note that I wanted to bring up too is up until recently, so in the last couple of years, once we hit R4, stringsAsFactors used to be set to default true, which meant that when you were reading in data using the base R functions, so like read table and whatnot, it would by default convert character vectors into factors, or data frame character vectors into factors. And there was a reason behind that. Once again, R comes from like a statistical background, and so they were trying to support statistical type work. Since then, there's been rethinking. Also, computers have gotten a lot better at storing, or like they just have more memory. So stringsAsFactors was a benefit back when R was first created, and maybe not so much now. We'll get into that a little bit. But let's go and first create a couple factor vectors. And so they can be really built from those base types that we talked about before. So you can have this character vector here, and you can just put factor around it and run it. And it's no problem, bud. Convert it into a factor. Same with Booleans, and same with numeric values as well. So it converts it. So this is our vector, and these are the levels of our factors. You can also specify, so levels are important. So the levels are defining what are the potential entries that can exist in our factor level here. And so by default, it accepts, or if you don't specify it, it's going to look at the contents of the vector that you're passing to factor and take a unique, basically, of all the different values and then alphabetically order them. And so you can see hello world, hello TidyX ends up with the levels of hello, TidyX, and world. Even though world was listed before TidyX, alphabetically it's after. And so we can run this one, this line 32 here, and you can see that our entries are only B, A, C, D, A, B, but we specified that our levels are all the letters of the alphabet. And so it's listing all of them here. And so but to be clear, the levels has to be a superset, or at least the same set as the entries that are going into our factor. So we can look at this. So say we're going to create this vector or factor vector here of hello world, hello TidyX. You can look at the levels that exist without having to print out your vector here using the levels function. So we're going to run that. And so these are the levels that exist for our XF vector or factor vector.
Mm-hmm.
So now we know about a little bit about the levels. Now we're going to talk about ordinality, so we're going to use the same idea of BAC, DAB. We're going to set the levels to be letters, and we're going to say ordered is true. And so what this is going to do is going to convert it. So now it's showing, okay, so we've got our values here, but we've got 26 levels. And by saying ordered is true, it's saying, okay, so A is less than B, which is less than C, which is less than D. So it's going to go all through the levels that you have and say the order in which you put them in is the order in which they matter. And the last one is the greatest one. And so you can reverse that order by reversing the order in which you enter in your levels. So now we're saying Z is less than Y, which is less than X, all the way up to A. And then finally, one thing before we kind of get into more like using factors and whatnot is I want to talk about the structure of a factor. So, wow, a structor. I can definitely type.
There we go.
So yeah, so we're going to use a dput function, which it's in base R. It allows you to look at like the underlying structure of the objects. Sometimes they use str, but here we're going to use dput. And so here you see that the hello world, hello TidyX factor vector is represented by two different vectors. One is an integer vector of 1, 3, 1, 2, and then a label attribute which has the vector hello, TidyX, and world. And so the way you want to think about this is it's representing this character vector as a numeric, an integer vector representing the levels that it has, and then another vector representing those levels that exist. And so this first entry in the vector is 1L, which means 1. And so that's saying the first entry in the vector is hello. Then it's 3. And so that's saying the second entry in the vector is the third entry in our levels, which is world. And so as you can see, you can kind of bounce back and forth. And this is kind of important to understand the underlying structure when you get into these next pieces here. Patrick, do you want to take us through this chunk here?
Yeah, one of the reasons why you might use factors over, let's say, like a normal character string is that factors are a bit more memory efficient. So if we run this code here, we're going to take a look at this. If you just run the actual vector that it was, yeah,
there you go.
So there we go. So we have, what is that? 10,000 entries of a whole bunch of different, basically a random sample of these, whatever it is, 8 words or so into 10,000 entries. And so we have this long, long vector of characters. We can turn that into a factor here. So we run this and then we take a look at it. And notice there's no quotes around it. It's being stored as a numeric level versus being stored as a character value. And so just to give you an idea of what that did to the amount of memory being used, it basically halved it. So it's easier for your computer to store the numeric values, the integer values, than it is to store those character words. So this is really useful if we're dealing with lots of big data issues and we don't want to run into memory problems. It's also useful sometimes if you're fitting models, and some models won't even allow you to use the character value within the model. But if you don't realize it, I've made this mistake before, if you don't realize that you haven't converted a character to a factor, sometimes you're sitting there and you're thinking like, why is this taking so long? And it's because it's trying to really chug through that character vector versus converting everything to a factor. So it is a big save on memory.
Yep, exactly. So then, as we talked about a bit before, the levels of factors is also like really important to it, because that is what's saying, that is the preserving the information about the vector you converted into a factor, and we can edit that very easily without having to edit all the entries in our vector. So let's create this vector again of hello world, hello TidyX as a factor. We've got this value here. So why don't we replace some of those levels? So we can use the levels function, to extract and pull out what the levels are. But you can also use the levels function and assign over the new values that you want. And so what we're going to do is, rather than keeping hello TidyX world levels, we're going to say amazing viewers are. So our viewers are amazing. So we're going to run that. And now we've updated the vector levels to be amazing viewers are. And so the vector, when we produce it now, amazing are amazing viewers. So it just replaced those values. However, one thing to note is that you cannot replace the levels vector with a smaller vector by default. Like, you can't do that. There are tools that exist in R. There's the forcats package that provides a lot of really cool functionality for it. We're not going to go into that package at this point. We're kind of just trying to discuss what are the basics of factors. Yeah. But the forcats package is a fantastic. If you're working a lot with factors, it provides a lot of tools to make your life a lot easier.
The other thing is, if you are setting the levels of your factors, and you, for example, if we go back up to the vec, the original vec, if we were to run that, if we were to do factor vec and and then do comma, do comma inside of there, levels equal C. And if we forgot one of these, so let's say we forgot, we'll just do, like, let's say we wanted to change, let's say we wanted to set the levels to be world and hello, and we forgot to put TidyX into our levels. Run it. So it actually will kick out an NA if you ever forget. So just keep that in mind, that you always are aware of it, because I've run into issues with this as well, where you're then plotting something or doing analysis and you're like, why am I missing things?
Where are the NAs coming from?
Yeah,
all the values should be there.
That's an important one to
and
think about.
This can happen. This can also just happen when you're doing this, and so you take this normal vector too. Not. I think I misunderstood what you said there, but if there's a value in the vector you're feeding into factors that doesn't exist in levels, it will convert it into an NA.
Yeah.
Which can be useful. So, keep that in mind. It's not always a bad thing that it does this. Right. But, it's a thing to keep note, and it's not going to tell you that you did that.
Yes, that's right. Mm-hmm.
All right, so factor conversion. So we converted several of our vector types into factors pretty easily, right? You just drop them in and throw factor or as factor around them, and they convert really, really nicely. It's not complaining about them. It's able to generate them, and they look how we expect them to. But what if we want to convert them back? So, say we ran them through a function. Or ran our data frame through a function or something like that. And now it converted all our vectors, or the vectors we cared about, into data frames. Or we were using the functions in base R to read in our data sets, and it converted, and we were using an older version of R, and so it converted them into stringsAsFactors. We didn't realize that needed to happen, or we didn't want that to happen. We don't want to go back and rerun our code. So how can we convert those back into the actual character class types that we do want? So with character, it's pretty darn simple. You just call as.character, and it will convert the levels back up in the entries back up to their label values, which converts them back into the character vector. It's all happy. You're all good. You don't got to worry about that at all. Boolean, same idea. Both of these have methods for conversion of factors back into characters. They wrote those. It's real nice. It does the thing that you want. The problem comes when you're dealing with numbers that got converted into factors. So, this has happened to me. I don't know why I did this or why this happened, but especially when I was a new R programmer, this happened to me a lot. Not quite sure why. But I would get numeric vectors that would get converted into factors. And then I'm like, oh no, I want them back as numeric vectors. So I just call as numeric on them. And to my naive eyes, it looked correct. However, I think we can all agree that this is not the same as this. Right? And that's because when you call as numeric on a factor, it's pulling out that integer representation of the factor, it's not converting them actually back into the numeric values. And so now it's a two-step process. First, you have to call as character to get it to convert, to apply the levels correctly. And then you call as numeric on that character vector, and that'll convert it into the values that you expect, which of course now maps the original values that we entered in there.
Yep.
So that is a thing that happens a lot. Well, not a lot, but it happens, and it can trip you up, especially if you're not expecting it. Yep. And it's of course not going to throw an error, because technically this is not wrong. It is getting the numeric values of the factor. So it's not wrong, it's just you need to know what the function's doing. Cool. So those are different ways that you can interact with factors, how you can build them up, how you can change the levels, which is a lot of what you'd be doing with a factor, with factor vectors. But how do we actually use them? What is their uses in real life? Because so far we just kind of messed around with them. Patrick, do you want to take us through regression using factors?
Yeah. Okay. So let's we'll load in Tidyverse, and we're gonna burn through the empty cars package here. We're gonna keep this as a very simple linear model. So we're gonna take empty cars, and we're actually gonna just create some factors. So when you load empty cars, originally cylinder is a numeric value. So it's an integer. Where is it? There it is. But it only takes values 4, 6, and 8, right? There's no like cylinder 3.7892, right? So it's 4, 6, and 8. So we're going to just convert that into a factor, and we're going to convert it into a factor twice. The first time, R is going to do its normal behavior of ordering these things and making them factors. So 4, 6, and 8, it's going to go in that order, factor 1, 2, and 3. We're going to flip it for the next one, and we're going to say, okay, let's create another factor. We're going to call it cylinder factor 2, but we're going to level it up as 8 is the first level, 6 is the next level, and 4. So now it's in a descending fashion. So we run that. And let's see what happens with respect to how these behave within a linear model. So the first simple linear regression, we're going to leave it as a numeric value. R is going to think this is as a numeric value, and it's going to build a linear model. The second version, we're going to use our cylinders with the factor levels 4, 6, and 8. And the third version, we're going to use our levels of cylinder with the factors 8, 6, and 4 in that order. And because we've set an order for our factor levels, the first level is always going to be the intercept. So let's take a look at how these models look. The first one, as numeric, what we're saying here is for every 1 unit change in cylinder, we see about a -3 or a 3 mile per gallon decline, okay, for every 1 unit increase in cylinder. For the second one, we only see 2 coefficients. We see cylinder factor 6 and cylinder factor 8, where cylinder factor 4 is the intercept. So what we see there is that's the mean miles per gallon for a 4-cylinder car within our observed data. When we go from a 4-cylinder car to a 6-cylinder car, we lose about 7 miles per gallon. And when we go from a 4-cylinder car to an 8-cylinder car, we lose about 12 miles per gallon. That drop from 6 to 8, that -11, is not reflective of a drop from going from 6 to 8. It's a drop from going from 4 to 8. Now, if we were to move to our second factor variable, where 8 is now the intercept. So again, we only have coefficients on cylinders 6 and 4. The coefficients for those are relative to the difference between the mean value for an 8-cylinder car and a difference between an 8 and a 6, and the difference between an 8 and a 4. And you could see that they're just inverse from what we see in the one above, right? 11.564 has now turned positive, because before it was the difference between 4 to 8, and now it's the difference between 8 to 4.
Mm-hmm. And this is the difference between 4 and 6 up here, and this is the difference between 6 and 8. So
correct.
That's why the
and
numbers
so
are not the same.
Yeah, and if we wanted to do the difference between each of those two cylinder 6, we'd have to re-level it one more time. This is essentially the way. So we have 3 categories. This is the way that analysis of variance would work. Analysis of variance is a way of comparing multiple groups. And it's a general linear model. It's regression under the hood. And this is how it works. It's just a releveling to show all of those differences.
Let's look at summaries of these. So this is the numeric, the
Yep.
factor going 4 to 8, and then the factor going 8 to 4.
And so notice that the summary for the numeric value is going to be different.
That's it? Okay.
All right. So because we're looking at the value, the value is thought to be numeric. Okay, if we scroll down, we see that the summary for this, we see the coefficients that we just saw. Notice that the R squared and the p-value, the adjusted R squared for the model between this one and the one above it are slightly different. And then if we notice in the next one, while the coefficients change, our multiple R squared, our p-value, those things for the model, those things are not different. These are the same models underneath. All that's changed is the intercept term, which then changes the difference in the levels of the coefficients. If we make predictions with this model, or these 3 models, which we can do in this single tibble here, we see something interesting. So for the numeric value, we put in 1 is just a fake value, like a 3.6, which you can't have a 3.6 cylinder car. But because it's numeric, it goes ahead and it makes an an estimation. If we tried to do this in one of the factor models and put a 3.6 in, we would just get an error. It's not going to be able to understand what that means because it doesn't know that level. We then did a numeric prediction with a cylinder 4 car, and we get a 26.4 miles per gallon, which is relatively close because we're still dealing with observed data here that between all of these models, the same, the data is similarly observed. It's not like we validated this on an external set. Notice that even though the coefficients were different in the 2-factor models, the prediction, just like the p-values and the r-squared values of the model, they're exactly the same. It's the same data under the hood. All we did was change the factors.
There you go.
And we can visualize these things as well.
Yes, exactly. So factors aren't only useful for regressions and statistics in that world. When you're using ggplot to do your plotting, or base R even too, I believe, factors have a strong impact on the way we can visualize our data. So we're going to use we're going to create some basic box plots for us to visualize kind of the data that we were just looking at here. So we're going to use ggplot to initialize our ggplot, throw in our empty cars F data set here, and we're going to create some box plots. And so these are going to be identical. The only difference is going to be our X variable here. So geom box plot, we're going to set our aesthetics to be X. In this first one, we're going to use cylinder, and we're going to use Y as MPG. So let's run this. Let me make our screen a little bit smaller there. Let's make us skinny at the top there. But as you can see, it generated a box plot, but it doesn't know how to categorize the sil factor, or the sil variable, the x-axis, because it's a numeric entry. So it's like, I don't know how to split those up. I'm going to call it all one.
And so it kicks you an error as well. It kicks you a warning about that as well. It doesn't know. It doesn't know what to do. Do you have a grouping variable that you want to use here? What's going on, right?
Exactly. So it couldn't split those out. But since we already have these factors, we can simply update our geom box plot to use the factor F, which is, remember, the ordering of cylinders from 4 to 8, and use the same Y and run it. It's like, I got you. I understand what you're trying to say. And so here it's now categorized because we have categories for our x-axis. So it created the box plots for 4, 6, and 8. And you can kind of see the results of our regression as well here, like indicating
exactly.
But this is in the order 4, 6, 8. If we wanted to change that order, remember how when we created sil F2, we said, no. We want our cylinders to be ordered 8, 6, 4. And so that is the order in which the levels exist in sil F2. If we run that, that's how it shows it up in the plot as well. Where first we have cylinder 8 cylinders, then 6 cylinders, then 4 cylinders, which is the reverse order, which is what we'd expect of sil F, which is 4, 6, 8. And so that is how we can use factors to drive how our visualizations look. If we want if we want variables to show up in a specific order, we convert them into factors, set the level to be the order in which we want them to appear in our plot, and go forward from there. And that is all we have for today on how you can use factors to perform your analysis, how you can interact with factors, and how you can use factors to impact your visualizations. Hopefully you found this useful. I know that I'm kind of having a good time going through some of these object types and explaining how exactly they use, because we've used them so often. And just gone forward and assumed that people understood what they were doing, how they worked, why we were doing the way, like we tried to explain the code, but we were just going forth and using them. And so hopefully you have also been enjoying us doing this. Leave comments down below or comment on Twitter, share with your friends if you think this is valuable.
Mm-hmm.
So with that, I guess we're going to call it. Thank you all for joining us for 106 episodes of TidyX. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. At OSP Patrick is where you can find me on Twitter. At tidy_explained is where you can find the screencast on Twitter. tidy.explained@gmail.com is where you can drop us an email, or if you'd like, you can go to the GitHub repo and open up an issue, or like and subscribe on the YouTube channel and drop us a comment or question there. I think that's the easiest way to probably interact. Seems like the most popular way. And as always, we appreciate everybody listening. And if you've enjoyed our work and want to support us in any way, we're appreciative of anything on our Patreon page.
Thank you all so much, and keep on exploring your world.